Okay, guys, we're going to look at about three more examples of multiplying rational expressions. Now, we're going to still follow those same steps that we've been following. And we're going to first look at number 4 here. So in this one, we're going to factor first. So v squared plus v minus 6, I'm going to use the diamond method on that. So 1 times negative 6, that's negative 6, and then I need to get a positive 1 here. So in order to do that, I would have to do a 3 and a 2. One's going to be positive, one's going to be negative, so it's going to be a positive 3 and a negative 2. So this is going to be v plus 3 times v minus 2 over, okay, v minus 2, I can't factor that any further. It's as simple as it's going to get. Times, okay, 4v minus 28. All right, that minus is a difference, but 28 is not a perfect square, so I don't have a difference of squares here. So do I have anything that's common to both 4 and 28? Yes, a 4. So I can take out a greatest common factor here, which will leave me with v minus 7 over, okay, 4v plus 12. Do these two terms have anything in common, a greatest common factor that I can take out? They do. They have a 4 in common. Okay, that will leave me with v plus 3. Okay, now that I've factored, we see what we can cancel out. So top to bottom here, I can cancel out v minus 2. Top to bottom here, we can cancel out our 4's. Now we look diagonally. Diagonally this way, I can cancel out the v plus 3. Diagonally this way, there's nothing to cancel. So the only thing that's left, if you look here on top, the only thing that's left is v minus 7. And on the bottom, everything canceled out. So we're just left with v minus 7. All right, now to state our restrictions, remember you go back to your denominator. So our v cannot equal, first of all, this one, to make v minus 2 0, that would be a 2, because 2 minus 2 is 0. And to make v plus 3 equal to 0, that would be a negative 3. So v cannot equal 2 or negative 3. And our answer is v minus 7 when we simplify. Okay, let's look at number 5. Okay, we're going to first factor. So I'm going to factor this top one here. I'm going to use the diamond method. I need to get a positive 27, 1 times 27, and I need to get a 12 in the middle, positive 12 in the middle. All right, so 9 times 3 is 27, and 9 plus 3 is 12. So this is going to be a plus 9 and a plus 3. So x plus 9 times x plus 3 over, okay, now I need to factor this one. Use the diamond method. 1 times 9, that's a positive 9 and a positive 6. So that's going to be a positive 3 and a positive 3. So this is going to be x plus 3 times x plus 3. All right, now over here, 8x squared plus 24x. Okay, it's not a trinomial, it's a binomial. It doesn't have a minus in the middle, so it's not a difference of squares. So do these two things have something in common, a greatest common factor that I can take out? Yes, they do. They have an 8 and an x in common. That leaves me with x plus 3 over, okay, x minus 9, that's as simple as it gets. So I can't do anything else to it. Okay, now we look top to bottom. Can we cancel anything? Well, I can cancel both of those x plus 3's. Top to bottom here, there's nothing we can cancel. So don't you try to cancel that x and that x, because this x is part of x minus 9, okay? Let's look diagonally. Can we cancel? All right, this one is x plus 9, and this one is x minus 9, so we can't cancel those out. Diagonally this way, we do have x plus 3 and x plus 3, so we can cancel diagonally that way. Okay, so now what are we left with? We're left with 8x times x plus 9 on top. Over, on the bottom, we're left with x minus 9. Okay, so that's as simple as we can get that. Now we have to list our restrictions. So if we go back to our denominators, okay, both of these are x plus 3, so that means in order to get that equal to 0, that would have to be a negative 3. Negative 3 plus 3 is 0. And then I still have the x minus 9. So to get x minus 9 equal to 0, x would have to be a positive 9. So this would be our answer with our restrictions. Okay, let's look at one more. This is a word problem, but I think once you read it, you'll understand what to do. The length of a rectangle in terms of x is this rational expression here. And the width of the rectangle is this rational expression. What is the area of the rectangle in terms of x? And it says to leave your answer in factored form. Okay, the area of a rectangle is equal to length times width. So basically what I'm doing is multiplying these two by each other. So it's the same thing we've been doing up here. X squared minus x minus 6 over x minus 5. That's the length times the width. X squared minus 6x plus 5 over x plus 2. All right, so we're going to start by factoring each of these. So if I factor this top one here, x squared minus x minus 6, 1 times negative 6 is negative 6, and I need to get a negative 1 in the middle. Okay, that's very similar to this one we did up here, but this time instead of a positive 1, I want a negative 1. So I'm going to just flip my signs here. It's going to be a negative 3 and a positive 2. So you'll notice after you do a few of these that they start repeating themselves. So x minus 3, x plus 2, over this x minus 5, that won't factor anymore. So we're going to leave that x minus 5, times, okay, well now we've got to factor this one. Okay, so we've got a 1 times 5, positive 5, and we need to get a negative 6. All right, in order for this to be positive, both of these have to be the same sign, and it has to be negative since my adding needs to be negative. All right, to multiply to get 5 and add to get 6, that's going to be a 5 and a 1. So this is going to factor to x minus 5 times x minus 1 over, we've got x plus 2 here. That's as simple as it gets. All right, top to bottom here, there's nothing we can cancel. Top to bottom here, there's also nothing we can cancel. So let's look diagonally. Diagonally this way, we can cancel the x plus 2. Diagonally this way, we can cancel the x minus 5. So you can see our denominators both canceled out. So we're just left with what's in the numerator, which is x minus 3 times x minus 1. And it said we can leave it in factored form. Now we still need to tell them what our x's can't be equal to. So let's look at our denominators. What would make this denominator, x minus 5, equal to 0? That would be if that's a positive 5. What would make x plus 2 equal to 0? That would be if x is negative 2. So this would be the area of our rectangle with the restrictions listed. All right, as always, if you have questions, let me know.